Today we'll start control dependence. So in control dependence, we are going to study what is if conversion and what is control dependence and how it can be solved by various techniques, what are the issues in control dependence. And then we'll see one of the method if conversion in detail to deal with this control dependence. So let's start with control dependence. To understand this, you take this example, very first example. You have a loop going from 1 to n number of times this loop will execute, and this loop is having two statements. Carefully read this example. Statement number S1 is a conditional if statement. So if in bracket condition a of I minus 1 greater than 0.0, then go to 100. S2 is a of I is equal to a of I plus b of I into c, and then continue. So in this loop, which is executing in number of times, two statements are there, S1 and S2. Now if you see S2, then it is a of I is equal to a of I plus b of I into c. So it is not having any dependence. So if you would like to execute in parallel, you can apply loop distribution here, and one loop will have S1, another loop will have S2. So the loop which is having statement S2 can be parallelized. Okay, so after the parallelization, or you can say vectorization, here we are using vectorization. So after vectorization, this the loop which is having statement S2 can be converted into a vector instruction. Okay, so just see the second program fragment, which is actually a vectorized code for the previous program. So S2 after vectorization it becomes a of 1 to n is equal to a of 1 to n plus b of 1 to n into c, and the another loop which you got after loop distribution is having statement S1. So we are presently not dealing with if statement, so we want to keep it as it is, and we will not discuss uh, any dependence related to if statement right now. So if we get this vectorized code, then whether this vectorized code is equivalent to the original code? No. Okay, so when you execute this vectorized code, you will get wrong answer because this is not equivalent to the original program. Meaning of original program and this vectorized program is different. Okay, so how it is different? So now we'll talk about meaning of the original code. So you see original code once again. Here statement S2 is after S1, and what is the meaning of statement S1? When you execute statement S1, it will check that condition a of I minus 1 greater than 0.0. Now the result of this condition may be either true or false. Okay, so nobody knows what would be value of this condition. Okay, value of condition would be known only at runtime. So at compile time, you cannot predict its value. Okay, but you are sure that its value would be either true or false. Now if its value is true, then what will happen? If value is true, then control will transfer to 100. Okay, which is having continue. So what does it mean? It means that if condition is true, then S2 would be skipped. S2 will not going to execute. If this condition is false, then control will go to next statement, which is S2, and S2 would be executing. It means that in every iteration of this loop, S2 is not going to execute. Okay, so whether in a iteration S2 will execute or not, that depends on statement S1, or particularly value of that condition. If condition is true, then S2 will not execute. If condition is false, then S2 will execute. Now what is the meaning of the vectorized code? Here meaning of vectorized code is statement S2 will execute n number of times irrespective of the condition, because first you are executing that statement n number of times and then you are entering into another loop which is checking condition. Okay, so execution of statement S2 is not having any relation with the condition. Okay, so meaning of this two program is completely different. Now why this happened? This happened because we missed one dependence here. Although when we have observed statement S2, within statement S2 uh, there is no dependence. Okay, and when we are talking about dependence, up till now we talk only about the data dependence. So there is no data dependence in S2. But you carefully see, and what we discussed in original code, that here the meaning is S2 will execute only depending on the result of S1. Okay, or in other words you can say that S2 is having dependence on S1, and this dependence is not because of data. It's not because S2 needs some data which is calculated by S1. No, whether control will reach to S2 or not, that would be decided by S1. Okay, so S2 is depending on S1 because of control dependence. Okay, so this is not because of data, this is because of control. Here the question is whether control will reach to S2 or not. So if condition is true, then control will not reach to S2. If condition is false, then only control will reach to S2. Okay, so this type of dependence is known as control dependence. So here if I have to represent this dependence, then I can represent it by the symbol that here S2 is having control dependence on S1. Okay, so this is control dependence. Now, how to deal with this control dependencies? Does it mean that the program which we have written cannot be vectorized? No, there must be some method to deal with such type of dependence. Okay, so we have basically two strategies to deal with control dependence. First is if conversion. In if conversion, we convert all control dependence into data dependencies, and then we have method to deal with data dependence. Okay, and second method is we explicitly expose control dependencies. So we have specific methods to deal with control dependencies directly without converting control dependence into data dependence. So now we'll see this method one by one. So let's start with the first method, that is if conversion. It is very important and popular method of dealing with control dependence. The idea here is to convert statements affected by branches into conditionally executed statement. So let's start with example. Same example we are considering, which we have seen to discuss control dependence. Okay, so this is same example. Now if I have to solve this problem of control dependence by using if conversion, then I will convert the statement which is affected by control dependence into a conditional if statement. So basically, if you see meaning of this program, then S2 uh, will be executed, or A of I value is calculated depending on that condition. So this program can be converted into one single if statement where we have the same condition. Okay, so if we have to give effect of that same condition, then we have converted S1 and S2 into single if statement, which is if a of I minus 1 is less than equal to 0.0. You see here, greater than is converted into less than, and if it is yes, then a of I is equal to a of I plus b of I into c. Okay, so these two program are equivalent. We have inverted the condition, greater than becomes less than equal to, because previously if this condition is false, then you have to execute the statement. So same we are doing in this program. So condition greater than would be false if a of I minus 1 is less than equal to 0.0. Okay, so then you have to execute the statement. So these two program are equivalent. Okay, so in if conversion, you understood that uh, if condition is there, then in if conversion you have to convert all statements which are affected by control dependence into conditional branch statement. So take one more example, little complicated. Previously we were having only one statement, now we have two statement. Okay, so all other things are same, condition statement is same. So S1 is exactly same, S2 is also same. We have added one more statement, S3. So if condition is true, then control will go to S2. It means that it has to skip both S2 and S3 if condition is true. If condition is false, both S2 and S3 would be executing. So here, how many statements are affected by control dependence? Two statements, S2 and S3. So both of these two statements would be converted into conditional if statement. Okay, so if I have to convert S2 into if statement, then I will write if a of I minus 1 less than equal to 0.0, then execute the S2. Okay, that is calculation of a of I. So it is exactly same as we have done in previous example. Now same we have to do for S3. So S3 will also execute if condition is false. Okay, so same condition, a of I minus 1 less than equal to 0.0, then b of I is equal to b of I plus a of I. Okay, so all statements which are affected here, in this case two statement S2 and S3 are affected, so both are converted into if statement by inverting that condition. Now once you have done this, then you can vectorize this program. Okay, so you have to execute both of the statement S2 and S3 n number of times. Okay, and since you are not having uh, any loop carried dependence, okay, you have only loop independent dependence, so you can apply first loop distribution here, and then after applying loop distribution you can execute this uh, using vectorized instruction. So here basically you have two loop independent dependence due to a of I and due to b of I, so it is creating a cycle. Okay, so you cannot execute both in um parallel. So one thing you can do is you can execute first statement in sequence, and then you can execute the second loop, that is S3, in parallel. Okay, so vectorized code for second loop which is having statement S3 would be, because if statement is there, up till now we have not converted if statement into vectorized instruction. So just see carefully, the equivalent vector instruction for if is, you have to use keyword where. Okay, so statement S3 is converted into vector instruction by using where. Okay, so where a of 0 to n minus 1. Okay, so this is condition. The condition would be same which is given in if statement. Okay, but you have to mention the value of range of I. Okay, so in condition, if you see in S3 in the previous code, then it is if a of I minus 1 less than 0.0. So what would be the minimum value of I minus 1? Minimum value of I minus 1 is 0, because minimum value of I is 1. So minimum value of I minus 1 would be 0 in low, and maximum value of I minus 1 would be, since maximum value of I is n, so maximum value of I minus 1 would be n minus 1. Okay, so statement would be where a of 0 to n minus 1 less than equal to 0.0, then b of 1 to n is equal to b of 1 to n plus a of 1 to n. So the remaining part we have done many times, assignment statement. Okay, but if statement and its condition, it's new for you, first time you are doing. Okay, so just carefully see this where statement. Okay, so this is a vectorized code. Okay, so in spite of having control dependence, we were able to convert it into vectorized code. Okay, so this is how we can do vectorization for control dependence using if conversion. So the statement which is affected by control dependence are converted into conditional if statement, and these statements are also known as guarded statement, or these are also known as guarded execution. Okay, why guarded execution or guarded statement? Because here the original statement is guarded by some condition. Okay, or you can say the original statement is protected or guarded by a condition, that before executing that statement, first that condition needs to be checked. Okay, so directly you cannot reach to that statement, directly you cannot calculate value of a of I in this particular example. You have to first deal with that condition. If condition is true, then only you will reach to that calculation. That's why statements are guarded statement. Okay, now one small thing is here. If you have seen in previous example, there are two statements, so same condition you have to write in every if statement, and sometimes these conditions may be complicated, and you may have number of statements, very large number of statements affected by the control dependence. So in every statement you need to write that very long condition, and which is to be inverted. So sometimes it becomes very difficult to understand or difficult to write this program. So that's why one small thing which normally we does in writing guarded statement is the original condition we'll evaluate it in one of the variable. Okay, one of the boolean variable will take, and we'll evaluate that original condition in that boolean variable, and instead of using that condition every time in every statement, we'll use that boolean variable. Okay, so that makes your program simple. So it will not change anything, but it will make simple to understand this program to generate this program. Okay, so one example is given here, the same example which we have seen. If statement is there, inside that you have one statement. So since it is affected by control dependence, statement S2 is affected by control dependence here. So what we'll do is we'll uh, generate guarded statement. So instead of writing that condition every time in guarded statement, we'll evaluate that condition in one of the variable. So here condition is a of I minus 1 greater than 0.0. So we will evaluate that in one variable, boolean variable m. So here m is boolean variable, and m is equal to a of I minus 1 greater than 0.0. So you can say that every if statement in the original program which is generating control dependence, for every such statement we will generate one statement in output which will evaluate condition in one boolean variable. Okay, so here boolean variable is m, it is evaluating the condition of s1 in original program, and after that every statement which is affected by dependence would be converted into a guarded statement, and in that guarded statement, instead of writing that condition after inversion, okay, we'll write or we'll make use of this boolean variable. Okay, so see carefully the next statement s2. Here we have written the guarded statement if, in bracket we have not written condition after inversion, but we have written not of m. And what is m? M is having the value of that condition. M is a boolean variable having value of that condition. It may be either true or false. Okay, so we are inverting that variable, that boolean variable. Okay, so this m is also known as guarded variable. Okay, so this variable is used to guard the statement, okay, which is calculating value of a of I.